Welcome back to the tutorial series on gravity data processing using the DGS MATLAB applications designed to process data acquired using the DGS 81A meters. So in the previous video, we saw how we could edit a configuration file. In this video, we'll now go ahead and process a survey flight and use the configuration file we edited. So from the process menu, click on the process menu. From the drop-down, click the process flight button. You will be prompted to select a series of files that will be required to process. Please make sure that you read the prompt that is written here so that you know exactly which files that you need to be selecting. So the first prompt asks us to select the configuration file. So that will be the meter processing file. Thereafter, you are prompted to load the DGS data file. So that is usually the DAT file, survey file. Note that with every process, the process log panel logs every step. So you can note that here. So after selecting the data file, you will be prompted to define a data cropping range. So you don't need the beginning and the end of the data recording. So I will define a data cropping range that is as close as possible to where the actual data is. That's one click and two clicks. Thereafter, you are prompted to load the GPS position file. So this file is the processed file that you get after processing the raw GPS file using Inertial Explorer. So I have my position file right here. So once you have selected the position file, if it's the first time you're processing, you will be asked to select the folder where the geodata can be found. So this is really the reference data, which in our case is the EGM 2008 gravity model. So I will just browse to where I have that folder. This will be provided by DGS. Note the gravity time shift value that is that pops up. Usually once you've selected the position file and everything, the program calculates the time shift between the meter gravity and the GPS data. So the prompt shows the final time shift and it should be about less than a second. So it was 0.5, which is okay. Thereafter, you will select, or rather you'll split your lines. So here you have to define the number of lines in your survey flight. In this case, I have 2 lines. So once you input the number of lines, you will then have an equivalent to double the number you have input of clicks. For example, now I've input 2 lines. Now I have 4 clicks to define the start and end of each line. So you have to be careful when you're selecting the lines. For optimal line selection, you should always prioritize the data segments that shows that the platform was stable at a constant speed and was going on a straight trajectory. So a good reference plot is the EOS. It gives you a bit of an idea about the platform motion and can help you identify which segments are linear. So we want data sections that have minimal variations in the EOX plot. So I'll go ahead and pick there and there. So after I have split the lines, the program will prompt me and ask me to select a horizontal axis reference for the plot. In this case, I'll just take the default, the longitude is okay for me. Thereafter, you will be prompted if you would like to save this flight. And behind, you have a plot on the trajectory of the lines. So, and if you check for any other plots as well, you have the free air plot here that shows free air against the longitude. Remember, we selected longitude as a reference. And also, you may be able to see the reference satellite data here, just so you can see if your data varies from this. So I will save this flight. So you either input Y for yes or N for no. So I will say yes. It will save the flight as a MATLAB file. So I will save it as flight 1 because I already have one set. So I will add something there, F1A. So I will save it. Thereafter, you are prompted to name each line in the survey. The default that the program will pick is the flight, how you have saved your flight. For example, I've saved it as F1A. So for each survey line, it will either take 1L. Here is your chance to either define if it's a tie line or a survey line. And you can input any like L for survey line and T for tie line. So in this case, mine are all survey lines, so I will just leave the default naming, but of course feel free to name it as you would wish. So for every line that I name, you will notice the trajectory is plotted in the pop-up plot behind this. So I will click that's okay. For the second line as well, that will be 2L. It's okay. And that completes the processing of the flight data. In the next video, I will show you how you can plot and assess the processed data.